This is AP Calculus!
Calculus. I couldn't do it.
Thank you guys. Alright. We are on our final lesson today. It is Friday. That AP test is coming up this upcoming Tuesday. Monday, you can do whatever you want. You want to play a game, that's okay. If you want to do some more review, that's okay. One day is probably not going to make or break your score, so I'm cool with whatever you want to do. And then Monday, there is no AP test, I believe. It goes straight into calculus as your next AP test. All right, so let's talk about number 5. This number 5 was pulled from your final exam this last Sunday. So we need to make a slope field. So slope field is worth 2 points, 1 point for all the zero slopes, 1 point for all the non-zero slopes. So how do you do slope fields? Does anyone remember?
You plug in.
Yeah, just plug them in. So let's start over here. I'm going to plug in -1. So -1 is x, y is 0. When y is 0, I get -1 on the top. And then it doesn't matter. This row should match this row because 1 and -1 for x are the same thing. It's going to be x squared. So I can do these two rows at the same time. So -1 divided by 1 is a -1. So -1, -1. We can all do that right now. And then when y value increases to 1, it's going to be 1 minus 1, which is 0. So these are going to be 0 slope, 0 slope. And I can even do the 0 slope right now for this one because I know that it doesn't matter what the denominator is as long as it's not 0. And it will still be a 0 slope for all of y equals to 1. Because y equals 1 means I have a 0 in the numerator. And then from there, again, I'm just copying this one and this one. Question, yes? I'm going to get that one later. I was just going to go up through here first. And I just did this one randomly because I knew it was super easy to do. And then when I plug in 2 for the height, 2 minus 1 is 1. 1 divided by 1 is 1. And 1. Okay, now I need to do these two, my last remaining two. So I'm going to plug in 2 for x, so I'm going to have 4 on the bottom here, 4 on the bottom. And then when I plug in 0 for y, I'm going to get -1. So this is going to be -1/4. So -1/4 looks like that. It's really not that great of a slope, I guess. I don't know how well my drawing was. And then up here I'm going to have +1/4. It works. It's definitely less than 1/2. Cool. So again, 1 point if you can get all of those, 1 point for everything else. So for part B, what keyword do we see in here, Rochelle and Arrow?
Particular solution.
Particular solution, yeah. So particular solution means we are going to separate, integrate, evaluate, and if you want to get that 1, maybe 2 points, isolate. So for part B, we are going to first separate. Separate. When I separate, I'm going to come back up here and I'm going to cross multiply. I'm just going to show all of my work here. So x squared dy is equal to y minus 1 in parentheses times dx. That's after cross multiplying like that. So after my cross multiplication, I need to get all the y's on one side, all the x's on one side. I usually like...
I have a question.
Yes, question.
Since x squared is in the bottom. Oh, wait, never mind. Wait, that's not... We're not supposed to do that, though.
This is one way of doing it. You're probably doing the shortcut way where you just move x squared into the bottom. That's fine. Like you probably you just move this dx to the top right, and then you move this y minus 1 to the bottom left. Oh, what is your way?
I was thinking just moving the x squared to the top, and then that way you can do the dy dx more better. That way it would be dy over y minus 1 equals x to -2 dx.
That works. Yeah, you can do it that way as well. There's 100 ways to do math. Well, in this case, at least 5. But yeah, so I mean, the straightforward way is just cross multiply, get things on the same side. So I'm going to divide both sides by y minus 1. So I'm going to get 1 over y minus 1 dy. Divide both sides by x squared, assuming x is not 0. Assuming y minus 1 is not 0 also. And I'm going to get 1 over x squared dx. Of course, I don't really like fractions, so I'm going to turn these into negative power. So y minus 1 to the power of -1 dy is equal to x to the -2 dx. That's technically not a step in separate, but I'm going to do that in preparation for step number 2, which is to integrate. So I'm now on to integrate. And just a heads up, when I'm doing part C, I need one line to do part C. It's going to be really not much, so just remember to leave like about that much room for part C. All right, so integrate. Now I'm going to do the integral. Let's switch colors again. No, I'll stay with black. Integral of y minus 1 to the power of negative 1 dy is going to be equal to the integral of x to the negative 2 dx. All right, help me out, class. What do I do?
Well, for this one, we're going to use natural log.
Yes, natural log. And then do I need taxman at all? Always think of taxman when you're going backwards. Do I need taxman?
No.
Nope. Cool. So natural log of, is it absolute value or parentheses?
Absolute.
Yes, it's always absolute when I'm going backwards with these. Absolute value y minus 1 and absolute value is going to be equal to, what's this one? Antiderivative. Let's have arrow do it.
Wouldn't you? No, okay, because it's absolute value. Natural log of the absolute value of x to the negative 2.
So I only do absolute value when I have a power of negative 1. When I have a negative 2, it's just straight on antiderivative. So add 1. So it's x to the power of.
Yeah, I totally missed that. 1 divided by negative 1. So
Negative 1, right?
x to the negative first.
Perfect. And you're forgetting one last thing, arrow.
Plus c.
Yeah, that free point. If you write plus c, it is an automatic free point. All right. And then from there, we need to, well, that's integrate. And then I think this one was just 1 point right here and then 1 point right here because this one was such an easy integral problem. And then from here I'm going to evaluate, so evaluate. So evaluate means I'm plugging in my initial condition. There's my initial condition. That means that my, I don't know what just happened there, that my x, let me scroll up, scroll down, let it reload. Hopefully that works. That means that my x is 2, my y is 0, so my x is 2, this thing is 2. So it's going to be negative 1 over 2 plus c is equal to natural log of absolute value 0 minus 1. Wait, did I do that right? I did, okay. And on the AP test on Tuesday, stop right here. Unless you're going to do all of that extra work for that 1 point, stop right here. You got the point. Don't worry about it. You evaluated.
We can't stop right here today.
We can't stop right here today because my class is harder than the AP test where you need to actually do the simplification.
Not gonna lie, I understand like wanting to simplify, but it's like I feel like there's just those people who like there's people like me like who get used to simplifying to the point where like, oh, I should just left it there.
Well, you know both ways now.
But then it'll just feel easy to you. Like you just end it and you're like, oh, I'm done.
But like that's hard though because you're so like used to simplifying, like you never realize once you're not.
What is the natural log of 1? 0. Yeah. What is the natural log of e? 1. Yeah. Those two you need to have memorized. So 0 is equal to negative 1/2 plus c.
Oh god, I thought it was 2000.
My music was like full blast.
Which means c is equal to 1/2. Cool, cool. All right, so that was the evaluate. Raise your hand if you want to see isolate.
Stop here.
This is where you should stop in my class.
Okay. Let's stop.
Let's stop. Okay, Rochelle, you agree? Stop.
If we have time, can we go back?
If we have time, we will go back. And that time, I will come back after you finish the recording of the video and you go on to that second page. Oh yeah, oh, hold on. So on part C, you kind of have to have it done, but let's do part C right here. I'm going to go little wavy box, wavy box. This is going to be part C. So say we found the particular solution. What happens when we take the limit as x goes to infinity? Well, you're just using top-bottom rules. So what happens if the top is bigger than the bottom?
Equals to 1. Oh, 1.
It's greater than 1.
Like it would be like the number that's on top.
Whenever the top has a higher exponent, it's d and e.
Oh, it doesn't increase.
I mean, you can say positive or negative infinity, but I think Ben lost the point because he said negative infinity or positive infinity when it should have been the reverse. If you just say d and e, you get the points. What
Is it because the bottom would be 0?
So I'm thinking of something that looks, here's an example what might be right here. So like if I have something like x squared over x plus 1, the top has a degree of 2, the bottom has a degree of 1. The top has a bigger degree, so this one, if I took the limit as x approaches infinity, it would equal d and e. So far so good. All right, let's undo all that stuff. All right, so what happens if the top is smaller than the bottom?
It equals 0.
There it is. So if the top is smaller than the bottom, it equals 0. And then what happens if you have that third case where the top and bottom are the same degree?
Then you have to do the biggest exponential, like the biggest number.
Yep, look at the biggest degree term, and then do what to it?
And then you keep the rest by itself. Like as in like say like there's like I don't know, touch this right
X squared plus 3x over 2x squared minus 7x. What would you do there?
So for this one it'd basically be 1 over 2 because you get the numbers.
Cross off all the small things, they're insignificant, then just, cancel out x squared and x squared, and it's 1 over 2. Exactly. We call those things a magic fraction, so that's what I'm going to write down here, but that's the giant procedure here, so I'm going to say magic fraction. Magic. And that's definitely not how you spell magic, Mr. Sindel. There you go. Magic fraction. All right, let's go on to some multiple choice. Number 17. All right, so we have horizontal tangents at x equals 2, right here, at x equals 2, and at x equals 5. It tells us that in the problem. Let g be defined by this accumulation integral. So talking about g, which is that accumulation integral, when do I have a point of inflection? Well, what is the definition of inflection point for g?
G double prime sign change.
G double prime sign change. Nice. So let's find g prime. G prime is equal to, in terms of f of t, what is it? It's f of, is it f or f prime or
F
integral of f?
Prime. Is it F?
When I take the derivative, I plug this x in here and then get rid of the integral.
Oh, F
Derivative and integral cancel out.
F of X.
F of x, perfect. And f of x, as Rochelle said, was height. And now when I do g double prime, that's equal to f, what is this? F double prime like that?
No, F double prime of X.
So that's slope. All right, so if I'm saying g double prime sign change, I'm saying f prime sign change, I'm saying slope sign change. So where do I have a slope sign change? Well, slope is positive, 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 then negative, negative, and negative, negative, then positive, 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 so at 2 and 5. Questions? On number 18. All right, so we have the xy plane, the line x plus y is equal to k, where k is a constant. What is the value of k? Yeah, this one was a hard one. So for this one, I know that this is the slope of the line tangent. So this equation right here, this x plus y is equal to k, came from y minus box is equal to, or y minus y1 is equal to slope times x minus x1. This function right here came from this point slope form. But they don't give us a number here, so we have to figure out what that number is. All right, and it's tangent to this graph.
Oh,
So we're going to find some things here. If I rewrite, let's go ahead and rewrite this equation right here. That's going to be y is equal to negative x plus k. Can we all agree that that is the same function? I just subtract x on both sides. What is the slope? Everyone write it down. The slope was negative 1. Negative 1. This negative 1 went right there. Okay. We know that if I distribute this, I'm going to stick with blue here. If I distribute this, I'm going to get y is equal to negative x, and then eventually somehow plus k. So what's, I guess I can give these variables too. No, there's an easier way to do this. Let's now take the derivative of this graph. Y prime is equal to what? 2x plus 3. This is the slope. What must the slope be equal to?
Negative 1.
-1. So I'm going to say -1 is now equal to 2x plus 3. Which means x is what? X is -2. Which means this is a -2. Now I'm going to do the distribution and figure out what this missing value is, because I still need to figure out what the y coordinate is.
You plug in -2 to the y.
Yeah, you plug in -2 to this function for the x's, right? Yeah, so -2, we'll write that down. This -2 gets plugged in here, and it gets plugged in right here. So what do I get when I do that?
-1.
So -1. All right, now I just need to rewrite it in this form, and I'm done. So if I distribute this all out, coming down here, I get, this is y plus 1, so I have to subtract 1 from both sides. Y is equal to -x. This is -2, -2, -1. -2 because -1 times a +2 is a -2, and this was a +1. I have to subtract 1 from both sides. Therefore, this k value right here is -3. Yeah, that one was a hard one. If I started struggling on that, I probably would have skipped it. But you definitely know somehow slope of the line, tangent, and somehow you're taking the derivative. Just you have to play with it until you get it. Cool, and is that the end of the video? Because this is page 3. Yeah, so this one you're doing on your own. So that's the end of the video. If we have time and you finish all of these multiple choice questions, we will come back up here to finish the 4th step, which is to isolate, to actually get the equation.